Okay, pre-calculus 20, we're looking at section 3.3, and this section is called completing the square. Okay, completing the square. Now, completing the square is a method by which we can convert standard form of a quadratic equation to vertex form. So let's just step back just a little bit, and let's take a look at this. This is vertex form, or I like to call it vertex graphing form. That's what we used to call it. So this is vertex graphing form. And the reason why this is helpful is because we can see two important things. We can see that the width of the opening is a normal width. That is, from the vertex you go over 1 unit, up 1 unit, and that point is on the parabola in both directions. And we know it's positive, so it opens upward. And I know where the vertex is. The vertex is at positive 4, comma, negative 11. So that's great. But what happens if we want to show this same parabola or the same quadratic equation in standard form? Well, going from vertex to standard form is really easy. All we do is multiply through and gather all the like terms, and boom, we're in standard form. So let me show you how that works. Again, you should write this down too so you can kind of see what's going on. And so we want to expand this out. Really, this is x minus 4 times x minus 4, and then minus 11 after that. So you know how to multiply binomials, right? It's the FOIL method, if you want to think about it that way. Multiply the first terms. So this is x squared. O is outside terms. That's negative 4x. And inside terms, another negative 4x. And then the last terms, plus 16. So that's how you expand the middle part. And now all we do is gather like terms. So I have like terms here, 2x terms, and I have like terms, 2 constant terms. So in very short order here, we're going to have a standard form of an equation. 16 minus 11 is 5, right? Okay? So vertex form, and there's standard form. Done. Easy. That's easy, but going the other way is tricky. Okay? Going the other way is tricky. Now, again, we can see a lot of benefit to vertex graphing form because you can see the vertex, which is actually pretty important. You can get the vertex fairly easily from standard form, as we've learned, right? You can go the vertex now from standard form. The x value, if you remember, is going to be equal to negative b over 2a, I believe, right? From last day. So if b is negative 8, let's just do this real quick. So we've got negative 8 over 2 times 1. And so what's that? That's 8 over 2 is 4. So guess what? Back from vertex form, the vertex had an x value of positive 4. Right? That's the vertex. So from standard form, you can get the x value pretty quick, but then you have to plug this 4 into x in both spots to get the y. So we can do it. But you are going to need to know how to convert this form of an equation back to vertex form. So standard to vertex. All right. So it's not always so easy, but let's see how we do that. So a little background here. The process is called completing the square, and this is in your textbook. So if we go back to the textbook. What I'm talking about here is just through the text. We're not going to talk about algebra tiles. Some of you may have good or bad memories from algebra tiles, I'm not sure. But we're not going to talk about that so much. We're just going to kind of head to completing the square. So this is in your textbook, page 183. And this is where I've kind of clipped this out from. And I'm going to show you, first of all, the philosophy behind it, then we're going to practice doing it, okay? So if you want to look just real quickly here, this is a summary of the process, and we're going to do this process, but this is the actual equation that we have written down on our notes. And so we want to go from here, the first line, to here, the last line. Now, let me just walk you through this before we actually do it. So everyone just pay attention here. Don't actually write anything down yet. Just watch. So right here, we have an x squared term and an x term and a constant. Here, what we have is x minus 4 all squared. Right here, this is called a perfect square. That's a perfect square in there. It's a binomial that's multiplied by itself, a perfect square. we do not have a perfect square inside the standard form here. We have to make a perfect square. So that's called completing the square is the process we're gonna do. So we don't want all separate terms. We want the x terms, we want those x terms and a constant, but not necessarily this constant, but we want to focus on these two, and I want to complete the square so I can write that like this. Because again, if I write it in this form, I boom, all of a sudden have the x value to the vertex. And then boom, the constant that's left over is the y value for the vertex. So I need to change forms. So completing the square, and this is the process, and I'll walk you through this. We need to kind of take these and go through a little process here to come up with this. So let's do it on the other side here. So where I'm at. Let's take, okay, so let's take this x squared, was it minus 8x plus 5? Is that what I had? X squared minus 8x plus 5. Okay, let's do that. Where's my pen? So everybody write this down. X squared minus 8x plus 5. And I'm going to convert that to vertex form by completing the square. All right. So what we do is we want to take a look at the x terms. Okay, so all of the x terms, there should be a couple of them, right? If there's no x term and it's just an x squared term, then it's really easy. It's actually already in vertex graphing form, right? Do you know what I mean? Like, don't write this down, but if you had this x squared plus 5, that is vertex graphing form, because this is like this, x minus 0, all right? So it's already in. So this is when you have this x term that's in the way. And it's like, okay, this is not vertex graphing form, this is definitely standard form. So what we do is you're going to rewrite this now, just like this, okay? You're going to, if this is a 1, that's great. You're going to put a bracket, and you're going to put x squared minus 8x. And then you're going to put plus blank with a bracket around the end, okay? So just follow what I'm doing here. You're going to take the x squared term and the x term, and you're going to put it inside brackets. And what we're going to do is we're going to have to fill this in, okay, to complete this as a perfect square. So let's put the plus 5 out here, because we can't forget about that. Okay. Oops. What did I just do there? Okay. So that's your first step. Take the x squared and put it in brackets. Okay. And again, this is when a equals 1. When a is not equal to 1, that's the next level, which I'll get to in a few minutes. And so you're going to say to yourself, okay, what do I need to put in here to make this a perfect square? To make this a perfect square. Well, if you want to make it a perfect square trinomial, you're going to have to be multiplying here x and then either plus or minus something, and you want it squared, right? So what number can I put in here so that it goes into this format? And here's the quick way of doing this. It's really easy, actually. Okay. So you take a look at your b value right here, and you cut it in half. You split it in 2. So negative 8 divided by 2 is what? That actually turns out to be negative 4. Now, when you split that in 2, to get this value, now you square this. So whatever half of b is, you square it. And that's what goes in here. Okay, so again, I'm kind of giving you the shortcut, and I'll explain in a minute why that works. But what's negative 4 squared? 16. Notice that it's always plus here, always. Because it doesn't matter if this is positive or negative. When you square it, you always get a positive answer. So that's why you do plus blank. Okay? Now, you're saying to yourself, wait a minute. Maybe some of you are saying, I just added 16 to this one side of the equation. How can I just do that? Well, you can just do that if you also take away the same amount in another part of the equation. So watch this. I'm going to do this outside the brackets. Then I've actually added nothing. I've added 0. So that's okay. Okay? So, this is what we have so far here. I've completed this this is now a perfect square trinomial. So I can write this as, and what was the half that we squared? It was negative 4, wasn't it? So that's what goes in here. Whatever it is that you squared to get this term goes right there. And you can expand this out on your own if you want, and you will get this. Okay, so it works. But we'll do lots of practice with examples. And then, of course, what you have to do is you have to combine like terms here outside of the bracket. So what's 5 minus 16? That's negative 11. And that should be the vertex graphing form that we started with right here. Okay? So that's a process called completing the square. And the key is right here. You add something inside the brackets to make this a perfect square trinomial, and then you subtract the same thing outside of the brackets to make sure that you haven't changed the nature of the function. Okay, so any questions on this so far? Go ahead and fire away if you have any questions. We're going to do lots more examples here, but I just want to know if... Okay, we're good? Good for now? All right. Okay, let's do some more examples. Okay, and again, these examples are when a equals 1. When a does not equal 1, that's a different level, which we'll do in a bit. Okay, so let's do another one. Y equals x squared plus 5x minus 13. Okay, let's do that. That is in standard form. I want to put it into vertex graphing form. So actually, you know what? Let's change that 5. Let's change that 5 to 6. Okay. The reason why I'm doing that, because this is going to be easier. We'll do the 5 one next. Okay. So this is as easy as it gets. So I want to complete the square. So guess what? I put x squared plus 6x plus blank inside some brackets, and I keep that 13 out there. And guess what? I'm actually going to do this now too, because whatever I add inside the brackets, I need to subtract outside the brackets so that I'm balancing that off. So if you're wondering how you go about doing this, I would suggest you do exactly this. Plus blank inside the brackets, minus blank outside the brackets. And we need to find out what number goes in here. Well, 6 divided by 2 is 3. 3 squared goes in here. So this is 9. So we add 9 inside the brackets, and we subtract 9 outside the brackets. It's as easy as that. Half of the b value, half of this x term value, square it, and you put it outside. Okay? And then you also subtract it here. So now what we've got is we've got y equals, this is a perfect square trinomial. So what is what goes inside the brackets here now? What plus or minus what squared gives us this? X, it's going to be x. And then what do I put in here? Do you remember what? 3. Okay, so it's going to be positive 3, because that's what I squared to get this last term. So x plus 3. Just really quickly, x plus 3 times x plus 3, that's going to be x squared plus 3x plus 3x plus 9. That's x squared plus 6x plus 9. See how that works? So it's good. Now what do I put outside the brackets? What's negative 13 minus 9 is? Negative 22. Boom. You're done. Now let's just check this out. Let's just check this out on Desmos. Or if you have your graphing calculator, what you could do is you could graph this one right here and graph this one right here. They should be the exact same parabola. So I'm just going to do that and just double check to make sure we got this correct. All right, so if we graph these on Desmos here, x squared plus 6x minus 13 is this blue graph right here. What's that vertex? Oh, the vertex is negative 322. Oh, it's looking good here. If I now graph the other one, look at that. They're exactly the same. Okay? The same. Okay, so there's our confirmation. So let's do the one with the one I started with the other time there. Okay, so what is it? X squared plus 5x minus 13. Let's do that one. Y equals x squared plus 5x minus 13. Boys, hey, turn around, boys. Okay, let's keep the talking to 0. How about that? Can we do that? That'd be awesome. Okay, so y equals. Now, I want to change this into vertex graphing form, so I'm going to take a look at these two terms, and I'm going to put those inside their own brackets. X squared plus 5x. I'm going to add blank with a bracket. I've got that negative 13 that's still out there, plus I'm going to subtract whatever I added inside here. Okay? All right, so now, if this is an odd number, or if it's a decimal, or if it's a fraction, or something like that, you still do the exact same thing. You half it, so divide it by 2, and then square it. So what's 5 divided by 2? 2.5. Okay, well let's just keep it as a fraction. Okay, I'm not really, again, in pre-calculus, because we're in pre-calculus now, we're going to be working with fractions and radicals, irrational numbers, exact values. Okay, I'm marking your tests, and not a lot of you did that one question right that asked for exact value. I need the exact value of sine and cos. Okay, you took your radical and you made it a decimal and rounded it off. That's not exact. So I mentioned that last chapter. I'll mention that again. When we're talking about exact values, it's really important for calculus that we don't round. We need to be exact. So we shouldn't be afraid of working with rationals or radicals. So let's not make it a decimal. Let's keep it as a fraction. And what is this squared then? So 5 over 2 squared is 25 over 4. Okay, so 25 over 4, that's what goes in there. Okay? And I subtract 25 over 4 out here. So again, I think probably most of us need practice being comfortable with fractions. So that's what we're going to do. We're going to make exact values. We're going to work with fractions and all that. So what do I write here? What is it squared? X, because there's an X there. Plus, because this is positive. And what did I square to get this black number over here? 5 over 2. So we're going to leave that as a fraction. And now over here, okay, you're going to want to combine these. And if we subtract numbers that involve a fraction, we need a common denominator. So this is now 13 over 1. So this is going to be, we need to put this over 4. So multiply by 4, top and bottom. What's 13 times 4? 52. So negative 52 over 4 minus 25 over 4 is what? That's 77 over 4. So negative or minus 77 over 4. Okay, so that's level 2, I guess, there, where you have a fraction. Okay, so these ones should be the same. If we graph those should be the same as well. I don't know if I'll do that, but yeah. I'll tell you what, why don't somebody with a graphing calculator, could you punch these in? Punch these two in and let's just confirm. All right, so level 1 is when a equals 1 and when b is an even number. That's level 1. That's probably the easiest completing the square that you're going to find. Level 2 is when a is 1 and b is not an even number. We're dealing with fractions and stuff. That's level 2. Level 3 would be when a is not equal to 1. So let me do some examples with that. What we can't do, okay, very, very important, what we can't do is just do this and say, hey, I'm going to complete the square using these two terms. We have to get rid of this, really. Okay, we cannot have this as a 2 in there. It's going to mess things up. The easiest way to do this is now to say, I'm going to factor a 2 out of everything that I see here, or at least the x terms. Okay, I don't have a constant with this one, so this one's kind of easy. But what you want to do is you want to do this. Factor a 2 out. And then I've got x squared minus 10x. Okay? So we do want to get it so that a does equal 1. When a equals 1, then we can do this completing the square process. But there's going to be one other thing that we're going to have to take real careful note of. So from here on now, we complete the square of these two terms. So we're going to write the 2 out there. Don't forget it. But we've got x squared minus 10x plus blank. And then I'm going to put a minus blank out here, right? So plus, you're going to add something to complete the square, but you have to subtract something at a different part of the equation to make sure that we haven't changed it. All right, so at this point, hopefully, you guys are already seeing what goes in here. So what do I put here? Really? Nobody? 25, thank you. Plus 25. Now why is that? What's half of negative 10? Well, that's negative 5. What's negative 5 squared? 25. That's what goes there. Now, this is the second piece where you got to be real, real careful. You cannot just put 25 out here. Why? Does anyone see why this is not correct? I cannot do what I did before.
Because you should multiply 2.
Okay, multiply 2. Okay, very good. Watch this, guys. I completed the square in here. That is correct. Everything is done right. But by me placing a 25 in here to complete this square, what did I actually add to the equation? I actually added 2 times 25. Do you see that? Because there's 2's out there? So I actually added 2 times 25. So I need to subtract 2 times 25, or 50. So that's kind of in the third level here, that's what you got to pay attention to as well. So you have to factor. Then when you complete the square, you have to take careful note of what you actually added to the equation. Okay. So this is 2 times x minus 5 all squared minus 50. And that should be the same as this, just in a different form. Okay? Any questions about that? All right, well, let's keep going. There's 3 important factors of getting better at something. You know what they are? Repetition, repetition, and repetition. It's just one. Okay. How about this? Y equals 3x squared minus 12x. Oh, no, I don't want to do that. That's too easy. Minus 14x. Ooh, this is going to be really hard. Plus 22. Oh, ouch. Wow. This is going to be tough. You guys are probably just going to be crying after this one. This is, I don't know. Okay, all right. So, some things we have to notice. A is not 1. Okay. I still focus on these terms right here, but I have to factor a 3 out. And you know what? You can factor a 3 just out of those 2 terms. Forget about the constant. Don't worry about the constant for now. Don't worry about it. So let's go y equals 3 bracket x squared, because I want a 1 here, really. Now, this really messes this one up, doesn't it? Because it doesn't divide evenly. Well, that's no problem. Guess what? That's 14 over 3x. Big deal. We're big kids here. You guys are like grown-up math people. Okay, and finish it off the way you normally would, right? Bracket, put that constant there, and then you got to subtract something out here. Okay, all right, okay. This is not a huge deal, except we have to figure out what negative 14 over 3 divided by 2 is. What is that? That is negative 14 over what? It's over 6. Okay. Now, can you reduce this? It might be really handy and helpful and easier on you to reduce this. So would that be what? Negative 7 over 3? Okay. So that's what's half of this b term. What do I do with this now to get this value? I square it. So that's going to be what? 49 over 9. Okay? 49 over 9. Is everyone okay, again, with this, the first 2 steps here? Factor the 3 out, find this constant term in there. You okay with that? All right. So what did I actually add to this side then by putting that 49 over 9 there? I actually added this, didn't I? Which is actually equal to 49 over 3. Again, simplify things when you can. Oh, yeah. No. Okay. Wait. Did someone say wait? Did someone say that? Did you get this? Am I stopping here? I'm okay? Okay, I'm seeing some heads shake. Okay, so how I got 49 over 3? I actually added 49 over 9 times 3. That's what I actually added. So when I simplify that, 3 times 49 over 9 simplifies to 49 over 3.
Sorry for the interruption.
Okay. So I actually need to subtract 49 over 3 out here then. Okay, so let's try and gather this all together. So 3, this is going to be x, and then that's a minus, so this is a minus. What is half of this? That was 14 over 6, all squared. Now I have to figure out what this is. I have to combine these terms. So 22, that's 22 over 1. Okay, times 3 is going to be 66. So 66 over 3 minus 49 over 3 is going to be what? Okay, 17 over 3. So that's positive plus 17 over 3. All right? So that is in vertex form. That is in standard form. So one note was made. Very good. 14 over 6. We need to write that in simplest form. That's 7 over 3. Thank you, Jack. 7 over 3. So write everything in simplest form. Now, grade 11s. Okay, so here's the key ideas. Please take a look at the key ideas and let me know if there's anything in there that you're struggling with just completing the square part. Okay. Okay, I want you to do question number 2 and 3. 2 and 3 for tomorrow. 2 and 3. Get some practice in. Question number 2 and 3. There may be more coming tomorrow, but with class is almost over, so I want you to do 2 and 3.